All right, everyone in the house, let's get her going. So I stand between you and the party, so let's get through this. Hi, everyone. I'm Todd O'Connor. I'm a senior SCM engineer at Adobe. I'm here today with Lars Schneider, technical lead for GitHub at Autodesk, and we're going to present Advanced GitHub Enterprise Administration. You might be wondering, what does Adobe and Autodesk have in common besides the similarities in our logos? And I will say that has not gone unnoticed. Well, in working with Lars over the last month on this presentation, we came to realize we're trying to solve a lot of the same challenges. And in talking to a lot of you this week, you're trying to solve those same challenges too. So we hope you get a lot out of our information and our presentation today. So here's the agenda for today. We have a lot of information to cover. Oh yes, there is one more thing. I think we've saved the best for last. Lars will show us something brand new, never seen before, and I think you're going to love it. The inspiration for this was a talk by David Mittman from JPL 2 years ago at Universe, so we wanted a big shout out to David, thank you. This is a graph showing a visualization of collaboration amongst your GitHub Enterprise organizations. And no graph would be any good without being able to display more information about that data, and Lars is going to cover this in more detail later. So let's get started with some tips for your general setup and configuration of your appliance. These are the topics I'm going to cover in more detail: server considerations, the admin center, your high availability and disaster recovery, as well as some other techniques. So server considerations. First and foremost, you want to be on a dedicated VM host. Lars and I both know from experience not to be on a shared host. Shared VMs on a shared host are going to steal your resources. You don't want that. This is one time where greed is good. You want the VM all to yourself. The next thing you want to look at is RAM. You want to allocate as much RAM as that appliance is going to take. The system makes heavy use of kernel disk cache to speed up many Git operations. Now, on my appliance, I have 455 gig of RAM. At any one time, I have less than half of that sustained use. So I'm at about 180, 190. So the remainder of that is being used as disk cache, and that greatly speeds up my disk reads and my I/O operations. And I know that by looking at the disk I/O graph, my read operations are extremely low. So you definitely want to allocate as much RAM as you can. The next step, the next piece to look at is your number and speed of your CPUs. Along with my 455 gig of RAM, I have 48 CPUs. This is something you're going to have to track over time. You're going to have to do a historical. You're going to have to look at it. You're going to have to adjust, add more CPUs, adjust the speed of those CPUs. Now, if you're ever in doubt about either of these, a great resource is to take a system bundle, send it into the excellent tech support folks at GitHub, and they'll analyze it, and they'll give you some recommendations. And later on in the presentation, Lars is going to talk about how to interact with the tech support folks. The next thing you want to look at when you're setting up your appliance is allocating as large a root partition as available as you can. Now, keep in mind that when you allocate your root partition, let's say it's 200 gig, you really only have 100 gig of that, because the other 100 is used for the upgrade process. So that 100 gig is where all of your logs are stored. From talks earlier in the day by Home Depot, we saw that they were analyzing clones and looking at other traffic and those sorts of things. And these users that are running these crazy commands, filling up your log file, if it fills up your root partition, you're really in bad shape. So up until 2.11, the only way that you could resize that partition is to completely rebuild the appliance. Very, very inconvenient. With 2.11 now, they've given you the capability to resize that partition, which is really nice. Now, in a stopgap measure, you could keep fewer logs. GitHub keeps 7 logs on disk at one time for rotation. So if you're really running tight, work with tech support, adjust your log rotations only until you can get that root volume resized. Other server considerations: use a staging server. We use a staging server. It's great for testing upgrades. It's great for testing that last feature I talked about, resizing the root partition. You definitely want to be testing and using a staging server. Now, one little fact is that your existing GitHub license will apply to that staging server, so you can spin it up, no problem. Use the GitHub backup utilities. This should just run on a dedicated VM. Doesn't have to be anything fancy, small little VM. Run your backups often. I run my backups 6, 7, 8 times per day And none of my backups take any more than an hour. So you run them frequently, they're going to be very small. And most importantly, make sure to back up your backup server. You don't want to have to be standing in front of a server down situation. A VP is asking, when's it going to be back up? And you don't know because you've never tested your backup restore process. Where can you test that backup restore process? On that staging server. Long-term log retention. Maybe it's a security policy at your business. Maybe you need to retain those logs for more analysis. Send your logs off server to something like Splunk. And you would do this in your management console. The admin center. Lars and I both look at a lot of the settings in the admin center to adjust our appliances accordingly. Force pushes. Do you allow people to force push or not? Force pushing rewrites history. You might want to consider that. Repository upload limit. This is one thing you definitely want to be setting. Don't allow the users to upload or to push super large files or any large files to your appliance. The large files contribute to size over time to your repos. Cloning operations get slower and slower over time as more versions of those large files come in. So definitely adjust your limits. Large file support, LFS. That's something new that's come out recently. You can keep your large files off of your appliance and maybe onto a dedicated Alembic storage, or maybe in a separate area on your appliance as well. Something to consider. And reactivating suspended users. Again, I saw a presentation earlier today where they were talking about suspending, unsuspending users through their self-service portal. You can reactivate suspended users automatically by checking this box as soon as a user logs into the UI through like a browser. Their account is reactivated, transparent to them. They don't even know what happened. Saves also on your licensing. So server, high availability, and disaster recovery considerations. You definitely want to be using a replica server. Now, in our model, we're a single server, so I have a single replica. One-to-one pairing. I cluster. If you're in a clustering environment, the cluster is going to act as its own high availability, so there's no replica there. Now, your high availability is going to depend on where you want to put it. Ideally, it's going to be close to your primary for speed, for recovery, but there are also some other considerations, right? If your HA is in the same data center as your primary and the whole data center goes down, you're kind of out of luck. So look to where you want to put that high availability server. Your DR system. This is typically set up at a remote distant site, and you build that from a backup restore process. And how long does that backup restore process take? You'll know that because you've been doing that on your staging server. Now, 2.11 goes one step further and has some geo-replication built in. So you can have read-only replicas at remote sites, but these would be read-only replicas for your end users to speed up their read operations. So you might need a replica in your London office, for instance. And the local users in London would be hitting that for their read operations. So some other techniques that we use. We have an overarching org owner. This utility account that we have is a member of every single organization. It's useful for data mining. We use it to build out a list of all the org owners so that people within the company know who to contact for access. My team doesn't grant access. I'll say, go talk to this team over here because they're the ones that manage their orgs. And they'll know if you really need access or not. So that's something that's useful. We aggressively suspend users that have both left the company and that are stale in a certain period of time. Our threshold for stale is pretty low. You might adjust it accordingly. And then if you're using that reactivate suspended users, if they are suspended, they hit the browser and log in, they're reactivated immediately. Considering selective pre-receive hooks, both Lars and I use pre-receive hooks at our company. Some things that you can look at, blocking certain file types. Don't allow secrets, for instance. Another thing would be checking for bug IDs. That's a common one. Some of the new features that you might want to investigate in the newer versions here, rate limiting. From experience, I turned it on. Within a couple hours, I had to turn it off. So you're going to have to check this out, look at the values, and maybe use something that we're going to be showing you a little bit later on to help you analyze your rate limiting. Dedicated Alembic storage, as I mentioned LFS earlier, you can put your LFS artifacts on a separate set of disks, maybe cheaper storage. And geo-replication. So let's talk a little bit about helping administrators. Here are the topics I'm going to talk about. One of the first things that I like to do is I want to leverage ghe-announce. One little unknown fact is that you can embed HTML into your command, so you can have active links. I often do that for my self-service portal, my wiki page of documentation, and some other things, especially a link to my staging server. People might not know where to log in. I'll also have a break, and I'll put in the second line announcing upgrades. Self-service portals, I mentioned some other companies are doing the same thing, building self-service portals. And you might think, well, why is this under helping administrators, Todd? It's helping me cut down on email to me. So accounts that can't log in via browser, for instance, can use this to manage their SSH keys. They can set up integrations where I don't want to share the secrets with someone to set up Jenkins or Jira or something like that. Here are some screenshots of our self-service portal really quickly. Folks can log in, suspend, unsuspend. Right now we have integrations with Fisheye, and they can manage their generic or utility accounts. Another set of screenshots drilling down in a little bit deeper. They can manage SSH keys, do SSH key verification, and again, suspend, unsuspend. A quick little screenshot here of what it looks like for our managing Fisheye integrations. We'll look to see who is an owner of the repo, and if you're an owner of a repo, it'll show up here. You can enable that, and you can also disable that integration. And this is great because now I don't have to turn over my secrets to you to set this up. You can just go to our self-service portal and you're done. And now I'll turn the stage over to Lars and he'll continue with the presentation.
Thank you, Todd. At first, I also want to introduce a new tool, and that is Scotty. Scotty is a collection of scripts for GitHub Enterprise administrators. And all scripts are open sourced, and you can download them from GitHub right there. In case you wonder where the name comes from, well, whenever I read GitHub Enterprise, I can't help it. I have to think of the spaceship Enterprise. And you know, Scotty is the chief engineer of this spaceship, so this is where the name comes from. So what can Scotty do for you? Scotty has two kinds of scripts, conveniently organized in two different directories. There's the reports directory that contains scripts that access your appliance in a read-only fashion. These scripts query the GitHub database and logs for all kinds of useful information. And then there's the admin directory. This directory contains scripts that modify your appliance, sometimes in undocumented and not officially supported ways. So if you use them, make sure you read and understand them. So how does a Scotty script look like? Well, all scripts have the -h or help option, which prints the description of the script and other available options. All scripts have also the -n option, which would perform a dry run of the script. That means the script would show you what it would do on your instance, but it wouldn't do actually anything. So let's look at the output of a typical Scotty script. Here we have the git version script. This script will show you what kind of Git clients interact with your appliance. This is very useful in case, for instance, you have a Git client with a vulnerability and you want to see which of your engineers actually uses this Git client, because you want to make sure that they all use the fixed version of Git, right? And when you run the script, you would get an output like that. You see what version and how many users are using it. And by default, Scotty generates these scripts over the most recent log data. That means usually over the last 24 hours. If you're interested in a greater time span, then you can pass the -a option to make Scotty look at all available log data. And that means usually over 7 days. All right, so much for the introduction to Scotty. We'll get back to these scripts in a bit. Let's talk now about GitHub support tickets. If you run into any kind of problem on your appliance, then you can reach out to the GitHub Enterprise support team. They are super knowledgeable, and their help is incredibly valuable. And they will be able to help you even faster and better if you write good support tickets. So what does that mean? First, search your previous tickets. Make sure that none of your colleagues did ask the same question already. Second, explain the problem kindly, short, and precise. Put yourself into the shoes of the support engineer when you write the ticket. That means, in particular, avoid company-specific slang or abbreviations or code names, because the support engineer has no way to understand them. Also, add details that might be relevant to the investigation. In particular, add steps to reproduce the problem. If you know the time of the incident, then provide that, ideally in UTC, because this helps the support engineer to find the relevant log data. Also, if a client is involved, then add all kinds of information around the client, the IP address of the client, or the versions of the software that the client is using. So the Git version, Git LFS version, browser version, operating system versions, these kind of things. And also, if the problem is related to certain users, then give the support engineer the usernames that are involved, the repository names, the pull request IDs, the issue IDs, these kind of things. And you know, sometimes a picture is worth 1,000 words. And in these cases, make a screenshot and add the screenshot to your ticket. And last but not least, set the right severity. And yeah, you know, not everything is urgent, right? So after you submitted your ticket, then GitHub will give you a support ticket ID. And you can use that to upload support bundles. A support bundle is basically a zip file containing all relevant usage and log data of your appliance. To upload a support bundle, you need to log into the administrative shell and run the ghe support bundle command. And 2 hints here. First, your appliance requires internet access to upload the support bundle to GitHub. So make sure that your firewall allows this kind of access. Second, the upload might take a while. In our case, it can take up to 30 minutes to upload a support bundle. So if you SSH into the appliance and this SSH connection from your local machine to the appliance drops, then the upload to GitHub would fail. Well, therefore, I recommend to run the ghe support bundle command in a screen session on your GitHub Enterprise appliance. Then you are basically safe from this kind of error. So a normal support bundle would usually cover the log data of the last 24 hours. In some cases, it might be useful for the support engineer to know about more historic log data. And in these cases, they would request an extended support bundle, and you can send that with the -X option. And then there are other cases where a problem affects your primary instance as well as your replica instance. And in these cases, you can use the ghe cluster support bundle command to send out a support bundle that contains log data from all your different, from your entire cluster. And then there's another case. And sometimes you might want to upload only a single file to make it available to a GitHub support engineer. And you can also use the ghe support bundle command for that. Just pass the -F option with a file name. And then there's one more case. To investigate certain problems, you might need to upload files from your local machine. For instance, if you capture TCP traffic to analyze network issues. And GitHub has no command for you here. But don't worry, Scotty has you covered. Scotty has the support bundle local attach command that you can use to upload any file from your local machine to a GitHub support ticket. And while we're at it, I also want to introduce another Scotty command that I think is very useful, and it is send ghe diagnostics. So for some tickets, a full-fledged support bundle might be too much. As I said, it takes a while to upload it. So in these cases, you could just send a very quick diagnostics report. This does not take more than a minute, and it gives the support engineer a very good first impression of your instance and an idea of the problem that you want to get solved. All right, let's jump to the next section, helping users. I want to quickly talk about some common or interesting problems that you might run into as a GitHub Enterprise administrators. I want to cover the topics unassociated commits, recovering branches, and completely delete Git repositories. OK, so some users might complain that their commits are not properly associated to them on GitHub. They would look like this. You know, your name with this little blue question mark behind it. Well, as an experienced GitHub Enterprise admin, you would know that the local Git config is not configured with the correct email address. And of course, this is easy to fix for a single user. However, everything becomes way more complicated if you're dealing with a large number of users, as Todd and I do. Therefore, we try to automate problem solutions as much as possible. And in this case, we have a two-step strategy. First, we've installed a pre-receive hook on our appliance. And this hook checks every commit for proper Autodesk email addresses. If the check fails, then we will still accept the push. However, we will show the user a warning message like this. And in this warning message, we briefly explain the problem, and we suggest the Autodesk Git environment as solution. The Autodesk Git environment is a script that configures a user Git client properly. That means it ensures that name and email address is set correctly for the user. But it doesn't stop there. It also checks that you are using the correct Git version, the correct Git LFS version. It makes sure Git LFS is installed. If it's not installed, it will install it. It will also check your authentication mechanism. Is your credential helper correctly set up? It will set up, it will create a personal access token for you to access GitHub, and all these things, and many more. So this Autodesk Git environment will also work on all platforms. It works on Windows, Mac, and Linux. And we have made very good, it was very helpful for us to get our, the clients of our engineers streamlined with that tool. And both of these tools, they are open source and available for you too. You can get the pre-receive hook from the GitHub Platform Samples repository. And you can get a generic version of the Autodesk Git environment from the enterprise config for Git repository on github.com. OK, next I want to talk about recovering branches. As you know, Git is made for branching. However, sometimes a user deletes a branch accidentally, and then their work appears to be gone. But no worries. Again, Scotty can help you here. Scotty has a script to conveniently retrieve all events of a repository. And then you can search these events for your branch name to find the deletion event. If you do that, then you will get a result like this. The first line shows the name of the branch. The second line shows the previous commit the branch was pointing to. In this case, 9.3 something something. And the third line shows only zeros. And that means, in Git speak, the branch was deleted. The previous commit is the interesting one. That's the commit we want to recover. So we copy the commit hash to our clipboard and go to the repository on our GitHub Enterprise appliance. And then we add /the commit hash to the URL. And this will bring us to the exact state of the deleted branch. And then we use the branch drop-down menu to recreate the branch. And that's it. We recovered our branch. However, for shared branches, and in particular for release branches, you should ensure that nobody deletes them in the first place. And I recommend to enable the GitHub branch protection feature for this purpose. OK, now I want to show you how you delete a Git repository properly. You know, Git and GitHub, they are pretty conservative when it comes to deletion. In most cases, you can recover things up to 90 days after deletion. And in general, this is good. However, as an administrator, you might have to delete repositories right now. Maybe the source code was sold, and you have to delete it for legal reasons. And again, Scotty can help you here. You can use the repo purge archive script to purge and script from your instance after you have deleted the repository. However, be careful. Even after running this script, you still need to delete forks, clones, and backups of the repository. So don't forget that. OK, let's jump to the next section. Let's talk about debugging Git and GitHub. First, I want to show you how you debug Git problems on a user client. Let's use this git clone command as an example. Usually, Git prints only minimal output. Here, for instance, we see some statistics about the clone. In case of problems, you want to exactly know what is going on under the hood. And if you set the git trace environment variable, then Git will show you all the subcommands that it runs. And this can be very valuable to understand a given problem. And if you set the git trace performance variable, then Git would also tell you how long every subcommand took. And this is useful to investigate performance-related issues, if you want to understand why a certain Git command is slow on your machine. But to be honest, the majority of problems that you will investigate as GitHub administrator are likely network-related. And there are two more environment variables that I want to show you. If your Git client communicates via HTTP or HTTPS, then you can set the git curl verbose variable to see what is going on between you and the server. If your Git client communicates via SSH, then you need to override the SSH command with verbose output to learn about the communication. And the result would look like this. There are many more environment variables that might be useful to you. And I highly recommend to read the Pro Git book to learn about them and many other interesting Git-related things. So much for the Git client. Now I want to show you how you can debug problems on the GitHub Enterprise appliance itself. I will go through some high-level GitHub components, and I will briefly explain what they do and where you can find their log files. The first component is ghe-proxy. This component handles all traffic to the GitHub Enterprise appliance, and you can find the log file at var log ghe-proxy.log. And this is a very interesting log file. You can learn what kind of requests were made against your appliance, and how many of them, and where these requests come from. And Scotty can help you to analyze this log too. The ghe-proxy request script will print statistics about the different requests that have been made. Next is the babld component. This component handles all Git traffic on your appliance. And the log file is located in var log babld.log. This log is useful to understand what kind of Git errors happen on your appliance. You can also learn what clients generated these Git errors. And again, there are Scotty scripts to analyze the logs. This can be quite useful because you as administrator, you will be able to see Git problems before your users do. And the babld component serves the Git content to the client. However, it will only do that after the user has successfully authenticated against GitHub. And babld uses the git-auth component to check the credentials. In the git-auth log, you can learn about HTTPS or SSH authentication problems. And you can also learn who of your users authenticates with username and password. And this is in particular relevant if you have an LDAP setup, as we have at Autodesk. If you have configured LDAP, then GitHub needs to check the username and password always against LDAP. So there's always a request against LDAP in addition. And if your LDAP instance is overloaded or down, then this authentication request against LDAP will fail, and subsequently, the request against GitHub will fail, and the user gets an error. And of course, that's a bad user experience. And that's why we recommend our engineers to use personal access tokens or SSH keys for authentication. That way, GitHub can check the authentication without any extra external requests. So much for the pure Git-related components. The next component is Nginx. All web traffic runs through this component. Behind Nginx, we find Alembic. Alembic serves avatar images, release binaries, and uploads and these kind of things. Behind Nginx, we also find Unicorn. And this is the actual GitHub Enterprise website, so a very, very important component. And again, we have Scotty scripts to analyze the errors in this component. And last but not least, we have the LFS server. And this component serves all the large files to your users. So this is a very high-level overview of the GitHub Enterprise architecture. But for me, this is super valuable, as it helps me to follow the technical discussions with the GitHub Enterprise support team. All right. In the beginning of this talk, Todd promised you one more thing. And I want to show you that now. I want to introduce to you Hubble Enterprise, a tool to visualize collaboration, usage, and health data of your GitHub Enterprise appliance. Hubble shows a variety of metrics, and I want to highlight a few of them in the following. You can follow along with our interactive demo on github.com on your own machine, right there. Let's start with collaboration. Hubble shows the collaboration on your appliance. It will render a chart that visualizes how many members of one organization contribute to other organizations. And this includes contributions made via direct pushes and via pull requests. If you hover over an organization, then you can conveniently see the contribution relationships. This gives you a good overview of what product and teams are the top collaborators on your appliance. And this is especially true if the organizations cover sufficiently different topics. I'm mentioning this because sometimes you will also discover relationships like this. These two organizations, they cover the same topic, and therefore the collaboration is not surprising at all. And in these cases, it might make sense to consolidate these two organizations into one. And with Hubble, you can learn even more. You can ask Hubble to visualize all relationships of a given organization. And this is especially interesting for organizations that share or that host shared code. Here, for instance, we have the shared components organization within Autodesk. And this chart helps us to understand how many engineers of each product contribute to the shared code. But Hubble doesn't stop there. It also visualizes how your engineers use GitHub. Here, for instance, we see the percentage of repositories that use pull requests on our appliance. And this can be an indicator for the usage of code review in your company. And pull requests can tell us even more too. Hubble shows the percentage of repositories that use pull requests with status checks. Configured status checks can be an indicator for CI adoption at your company. And with Hubble, you can also look at clones and fetches on your appliance. And here's a typical example. The green line shows the number of fetches per day, and the red line the number of clones. And as you can see, we have more fetches than clones. And this sounds reasonable. As a Git user, you would usually clone once and fetch many times. So all this looks OK. However, if we look at the actual amount of data that was transferred, then we can see that clones cause much, much more traffic than fetches. And if you think about it, this actually makes sense, because a fetch only transfers the latest changes. A clone, on the other hand, will transfer the entire repository with all its history. And in many cases, users perform clones where they should rather use fetch. But how do you identify these users? Well, Hubble helps you here too. It prints a table of the repositories and users that cause the most traffic on your appliance. Let's use the Akamai repository as an example. The repository is just 200 megabytes in size. However, a misconfigured CI process clones the repository 1,200 times a day. And this causes 250 gigabytes of traffic a day. And these kind of things happen, and believe me, a lot. And a user's behavior like this will stress even the most powerful GitHub Enterprise appliance. And with Hubble, you can address these kind of issues by contacting the responsible teams and solving the issue. And after fixing these issues, the CI processes will usually even be faster, as fetching is always more efficient than cloning. And the overall performance of your appliance will also be better, because you have more resources available for all users. So everybody wins. So there's more to come. We released Hubble just 2 weeks ago, and we have lots of ideas for the future. We are also interested in your ideas. It's all open sourced and on github.com, and we would be delighted to receive your pull requests. OK, so let's wrap up. What tools for GitHub Enterprise administrators have we discussed today? We have discussed Hubble Enterprise, a dashboard for your GitHub Enterprise appliance to monitor and visualize collaboration, usage, and health data. We have discussed Scotty, a collection of helper scripts for your GitHub Enterprise appliance. We have briefly discussed Enterprise Config for Git, a script that configures the Git client consistently in your company. And we have discussed GitHub pre-receive hooks that you can get from the GitHub Platform Samples repository. You can follow me on Twitter for updates on Hubble, Scotty, and Enterprise Config for Git. And now, Todd and I, we are happy to take your questions, either here or later via email. Thank you. OK.
Hi, thanks. I have a question about pre-received hooks and file types that you were talking about earlier. I'm wondering if you're using the actual file utility to go hit that particular file. Are you introspecting the, you're not?
No, it's based on file name. It's the pre-receive hook on blocking files. Okay. And that actually, the one that we're using is actually in what is the URL, the contribution for all of the pre-receive hooks?
There, platform samples.
Yeah, the platform samples. So it's actually a default one that's already out there, and you just change the default names. So yeah, you have to keep in mind with those pre-receive hooks, you've got like 5 seconds that the thing has to run in. If it runs any longer than that, it's just going to block the whole thing. So it's got to be really, really fast. So we just look at really simple file names. Yep.
Okay. Okay, there was a comment that you can disable username and password authentication in the GitHub Enterprise admin settings. That is true. However, 2 problems. First, many people are using it still, and it would break many things. And second, username and password authentication is useful at times. If you just log into a server, clone a repository, it's nice to have it. It's just, we don't want to have people making like 30,000 username and password requests a day. And we have this a lot. So,
we fixed that because we don't use LDAP. We use SAML. We use Okta. So none of our users can log in with their LDAP credentials. So that might open up a different set of challenges for your organization, depending on what you want to do.
To expand on that answer, so will a user have 2 sets of credentials?
Well, they have their overall Adobe login, username, password, but to log into GitHub and many of the other services, it's going to be 2-factor. So ours is 2-factor.
okay. Can you
do Hubble or Scotty respect corporate proxies?
So the question was, do Hubble or Scotty respect corporate proxies?
Yeah, works with both. So basically, wherever GitHub Enterprise works, both tools work. Yeah, okay. Scotty SSHs into the GitHub Enterprise directly and performs these undocumented commands. So that's why it has to work, because you as GitHub Enterprise administrator, you have to be able to SSH into the appliance. So if you can SSH into, Scotty can. Yeah.
I'm sorry? How do we QA changes to our pre-receive hooks? That staging server. So we test everything over there, and we'll also go through a code review process, probably much like yourself. You know, we always get bit by the single person writes it, the single person reviews it, single person tests it, right? So if Lars were on my team, I'd say, hey, Lars, I've just wrote this cool pre-receive hook. Could you, check it out and go through there? But yeah, we definitely want to throw some things at it and test those on the staging server. Yeah. Nothing gets to our live instance, because if it gets there and it breaks, we hear about it really quickly.
That is totally true. And you can, for the pre-receive hook, you can put them in kind of a testing mode so that they won't affect anything. They would just make an output. And this is something that will come to Hubble, that you see how many of your pre-receive hooks actually would fail. Because we can see that in the logs as well. So if you make a change to a pre-receive hook and it fails all the time in this demo mode, then you would know.
Question over here.
What are you doing with pre-receive hooks to validate email addresses? Both of you mentioned that, but that can be a little tricky because often that involves some external access and that sort of thing. Just wondering what you've chosen to do in there to
Okay, so
reasonable and that sort of thing.
So the question was, how do we actually validate the email addresses in this pre-receive hook? And the answer is we cheat. So we just check that it is, in our case, we just check that it is an @Autodesk email address. Our experience shows us that this is sufficient for our purpose, and this check is very quick. So as Todd mentioned, we need to be under 5 seconds, and this is how we do it.
Kind of the same. No one can log into our GitHub unless they have an Adobe account. So we know what that address is, and then we only send email to @Adobe. So similar thing. We're just going to assume username @adobe.com. So that's what we do.
Yeah.
Question?
How many pre-receive hooks do you have, and do you do any logging of the activity of the pre-receive hooks?
How many pre-receive hooks do we have, and do we any logging? How many do you have?
Yeah, actually, we have just one right now. I mean, we're testing others, but only the email one is really active in production right now. And With the logging, as I said, we will put something in Hubble to monitor previous folks for the future.
And at that, we're out of time. Maybe one last question, then I don't want to stand between you and the party. So last one. How did we learn? The question is, how did we learn about sizing our instance, the caching, and all of the things that go into making a healthy GitHub Enterprise appliance? And I think going back to my talk from last year, it's that thing called experience. The thing that we get when we don't get what we wanted. And I know over time, we've had to rebuild our instance several times. And it's also working with GitHub support. I'd send in support bundles, and they'd get back to me and say, hey, Todd, you know, you've got a lot of CPU load. You need to add more CPUs. Or you're really high on your RAM usage. You really need to get more RAM on your instance. So we'd go through and we'd adjust those thresholds accordingly with the help of support. But now with Hubble, Scotty, and a lot of these other tools, we can find out some analysis and some details and some trends within our appliance. How about you? How did you go about scaling your appliance? Over time, trial and error?
I think, yeah.
Through experience?
Same answer.
Okay, sounds good. Well, thank you everyone for coming. We'll be around tomorrow. Enjoy the conference.